Hello, my name is Sam Philpott, along with my group members Kevin, Samaya, and Carson. We will be presenting Chapter 15, Big Data, Structured and Unstructured, from the book Big Data and Business Analytics. There are two types of data, structured and unstructured. Structured data is data that is created and intended for computer processing, such as Excel. Unstructured data includes everything else and is the language and communication that people use. There are no computer programs today that can translate unstructured data into structured data. The pathway to this goal is NLP, or natural language processing. One key concept to understanding NLP is lightweight and heavyweight semantics. Lightweight semantics are used, for example, by Google. When Google reads a book, it indexes the words without any attempt to understand what they mean. However, when a person reads a book, they are using their background knowledge to interpret each line of text. This is heavyweight semantics. Take the sentence, Bob drives his Chevy to St. Louis. Although this is a simple sentence, it requires heavyweight semantics to understand the meaning. In this conceptual graph, the orange boxes are concepts and the green circles are relations. The agent driving is the person Bob. The theme of driving is a Chevy. The destination is St. Louis. Bob possesses the Chevy. The Chevy has the attribute old. This conceptual graph represents a small amount of knowledge. The power of a knowledge representation comes from the interconnection of many graphs in the four following supporting resources and processes. Ontology is the study of existence. An ontology is the definition of the concepts and relations used to describe the things that exist in an application. A knowledge base includes an ontology, the database or graphs that use the definition in it, and the rules of axioms that specify reasoning with knowledge. Inference engines process the rules and axioms to reason with and about the knowledge. Heuristics uses statistics and information methods to process the knowledge in a variety of ways. At this time, I'm going to hand the presentation over to Kevin.
For my part, I'm going to talk about commercially available NLP systems and the technology approach. Beginning with commercially available NLP systems. These on the slide are just a sampling of the commercially available NLP systems, two of which are very common to the mainstream public in IBM's Watson, which powers phone apps like the Weather Channel and famously won Jeopardy, and most well known is Apple's Siri product. The other two are innovating into very critical industries, the medical field and law enforcement. The first app is called Speak Freely, and it allows doctors to dictate notes about a patient visit and convert it into understandable terms for doctors to recall later. The second is Discovery Alert, which collects and continuously monitors various kinds of large-scale, high-volume data, both structured and unstructured, and enables its users to conduct interactive, real-time queries in a conversational, natural language. Both of these innovations are setting the stage for the future and are just scratching the surface of what NLP is capable of doing for all of society. The next piece I'd like to talk about are common features of big data language understanding. The authors provide their viewpoint of what they believe to be common features required for all big data language understanding platforms. They believe the first is a seamless user interface which utilizes advanced speech recognition and natural language processing to unstructured human communications into machine understandable information. The second is a diversity of technology, which utilizes various methods of data collection and analysis tools to accomplish the required tasks. The third, new data storage technologies, uses software like not only SQL or NoSQL, which can allow for efficient and interoperable systems to be stored and utilized using various reasoning methods. Reasoning and learning artificial intelligence will help machines learn from mistakes and prevent the same mistakes from happening in the future. Finally, model-driven architectures, or MDA, which will make a real-world platform that understands colloquial conversation possible with machines. That brings us to the next question. What drives big data NLP? There are 5 factors that drive this process, and they are entity identification, which allows the computer to extract files and populate databases; language understanding, that makes it possible for the computer to understand the grammar and meaning of words in a language; causal and explanatory reasoning, which is the ability to formulate scenarios of activities and to create explanations based on its understanding. Voice and data in an NLP setting will need to be able to understand interjections, noise, and ambiguities in sound and context. Finally, there is knowledge representation and models, which in simplest form means that for a model to exist, there needs to be an ontology. And for an ontology to be built, representation of knowledge needs to be chosen. These 2 processes need to work in concert for this to be successful. Now let's move into the technology approach. And to begin, we want to define what the technology approach is. The technology approach represents the choices that are made to handle big data NLP in a typical life cycle that consists of knowledge representation, implementation language, and systems integration. This choice will have a total cost of ownership that is associated with it, and an NLP system must also take into account that system for knowledge extraction may need to handle the complexities of our natural language, such as discourse representation, intratextual references, resolving analogies, metaphors and similes or allegories into thematic semantic knowledge structure, and storing these for use in an interactive question-answering module. There also must be a consideration of data and whether it is structured, unstructured, or semi-structured. The authors point out that as a major consideration of the mix of data, that the best choice is usually a hybrid combination of several approaches, since data typically is partially a mix of unstructured, semi-structured, or fully structured components. Finally, we want to talk about the categories of approach options. The authors break down the many possible approach options to 3 categories: statistical, which all use a number of mathematical equations and statistical properties of words and collections of texts; algorithms that you may find out more about on the web that are representative of the mathematical approach have such names as latent semantic analysis, or LSA, vector space methods, or VSM, or the hidden Markov models, or HMM. These systems count and rank words and phrases. Next, we have template methods, which are the oldest of the methods, having been around since the 1960s, and essentially consist of a fill-in-the-blank type sentences. An upgraded version exists called finite state automata, which can process large volumes of semi-structured data at very high speeds. Finally, the linguistic methods are the most sophisticated of approaches and generally need a background base of knowledge, an ontology, a knowledge representation, and a variety of recipes by which text is assigned to concepts that identify the meanings. For example, models such as discourse representation theory, or DRT, model the meaning of not only sentences, but also how they relate to each other in paragraphs and the whole text. Other models, such as rhetorical structure theory, or RST, express how the topics and focus of the text is related to the intent of the author to the reader. This method allows the system to interpret meanings and answer questions. Now it's time to turn it over to the next member of our team, who's going to cover implementation and systems integration, ambiguity, and context.
There are 2 options to natural language processing system integration. One can create an original NLP system or use ready-made or open source components and libraries of software. System integration using ready-made sources and libraries of software work by integrating their functionalities into a desired capability. This is the most cost-effective approach because no research on the development of core components is needed. One must, however, understand the benefits and limitations of using software language choices such as Java, C, C++, Scala, and Prolog for a target device, say an iPhone, Android, desktop, or laptop. In addition, the size of the client base or whether or not it is web services based is also a key factor which must be taken into account when considering which NLP system must be used for integration. For instance, in a wide audience, such as in customer management and support, the need for a powerful and seamless NLP would be a requirement. The choice of language is very important when considering NLP integration. Languages such as Java, Scala, and Prolog all benefit from Hadoop and its ability to build a cloud with NLP service components. This table provides a list of the most commonly used programming languages and the advantages and disadvantages of their use. Programming languages such as Java, C, and C++ can run without external applications. They possess seamless language integration and interface very easily with Microsoft and Windows. However, they are not designed for reasoning tasks. Not only that, but the algorithms must be written at a very low level, which makes them very expensive. Programming languages such as Python, Prolog, Lisp, Haskell, and Scala serve as a backbone for cloud technologies and have high-level programming. However, the runtime must work harder than that of Java's. In addition, writing efficient codes is very difficult, which means it is much slower. Natural languages are the most complex form of communication and knowledge encapsulation. They can only be executed through the presence of human element. The natural language processing and natural language understanding system integrator is faced with a major problem since language is highly variable and flexible in its use from one individual to the next. Here are a few examples. John went through Harry to get to Paul. Did John go through Harry physically or what? Here's another example. He was a lion in the fight. How can a human be an animal? This is totally impossible. To solve this problem, NLP programs restrict the context by allowing what words a user can use. A controlled natural language would only understand language in a highly rigid form which can be learned by humans. An example used by the author is the medical language of radiology reports, which has been learned by humans and also by machines effectively. Right now, I'll hand over to Kevin, who will present the future directions.
Hello everyone, and thank you for watching our presentation. I'll begin with the future, where the future holds for structured and unstructured data and the natural language processing. First, there are three current and significant projects. One is the SITE project, which is an application that has developed the world's largest ontology. Second, there's the IBM Watson, which is a supercomputer who beat the world champion in Jeopardy. And third, there is Prolog, which is language-based agent at VivoMind Research, where the researchers are building on the intelligent agent paradigm. Understanding Prolog language-based agents is quite complicated. But I'll keep it brief in this presentation. A language-based agent is a program framework centered on common sense and practical reasoning. The researchers at VivoMind are building on the intelligent agent paradigm, which may lead to ultra-smart clouds of autonomous algorithms that know which NLP task they are best suited for. In effect, the agents program themselves. We can use the ordinary language to tell them what to do, but not how to do it. What is cloud-based natural language processing? Natural language programming. It is just another program where you can create your own application. And the cloud API vendor provides all the algorithms. There are a few applications to cloud-based NLP. They include social network mining, website analysis, and news analysis. Natural language programming template-based systems are becoming quite useful in today's world. They use keyword and key phrase extraction templates using word list or thesaurus. At the simpler end of the spectrum, especially for specialty jobs such as order processing, the template-based methods are very hard to beat for speed and scalability. In the case of semi-structured text, for example, the air traffic information dialogues, template-based systems are ideal for information extraction. In conclusion, open source tools are improving, and IBM's Watson has used many of the open source components discussed. There are many more companies and specialty component technologies currently on the market. Some, like the intelligent-based connotate, already have a strong lead for the scalable and the distributed natural language programming languages.
Thank you. And finally, we want to cover the 3 dimensions of analytics and how they apply to this chapter. The domain is service analytics, web analytics, and software analytics. The orientation is the SPED model, and the technique is dealing with structured, semi-structured, and unstructured data. Thank you very much for watching our video.